Hi, my name is Vinay and I'm a data scientist. We are here to learn about this unsupervised learning in Python. Unsupervised learning is a class of machine learning techniques of discovering patterns in the data. For instance, finding the natural clusters of customers based on their purchase histories or searching for patterns and correlation among these purchases and using these patterns to express the data in a compressed form. These are examples of unsupervised learning techniques called clustering and dimension reduction. Unsupervised learning is defined in opposition to supervised learning. An example of unsupervised learning is using the measurements of tumors or to classify them as benign or cancerous. In this case, the pattern discovery is guided or unsupervised so that the patterns are as useful as possible for predicting the label. Beyond or cancers, unsupervised learning in contrast is learning without labels. It is pure pattern discovery, unguided by a prediction task. You will start by learning about clustering, but before we begin, let's introduce a dataset and fix some terminology. The iris data consists of measurements of many iris plants of 3 different species. There are 4 measurements: petal length and petal width, sepal length and sepal width. These are the features of the data set. And throughout this course, data sets like this will be written as a 2-dimensional NumPy arrays. The columns of the array will correspond to the feature. The measurements of the individual plants are the samples of data set. These correspond to rows of the array. And the samples of the iris dataset have the 4 measurements, as I said, and so correspond to points in a 4-dimensional space. Yeah, this is the dimensions of the dataset. We can't visualize 4 dimensions correspond directly, but using unsupervised learning techniques, we can still gain insight. In this chapter, we will cluster these samples using k-means clustering. K-means finds a specified number of clusters in the samples. It's implemented in the Scikit-Learn or SQL-Learn library. Let's see k-means in action on some samples from the iris dataset. The iris samples are corresponding as an array. To start, import k-means from SQL-Learn. Then create a k-means model specifying the number of clusters you want to find. Let's specify 3 clusters. Since there are 3 spaces of iris, now call the fit method of the model, passing the array of samples. This fits the model to the data by locating and remembering the regions where the different clusters occur. Then we can use the predict method of the model on these sample examples. This returns a cluster label for each sample, indicating to which cluster a sample belongs. Let's assign the result to a labels and print it out. If someone comes along with some new iris sample, K means can determine to which cluster they belong without starting over. K-means does this by remembering the means or average of the samples in each cluster. Now, there are called the centroids. Now, samples are assigned to the cluster whose centroid is closest. Suppose you have got an array of new samples. To assign the new samples to the existing cluster, pass the array of new samples to the predicted method of the K-means model. This returns the cluster labels of the new samples. Here it is 0 to 1. The next video you will learn how to evaluate the quality of your clustering. But for now, let's visualize our clustering of the iris samples using scatter plots. Here is a scatter plot of the this is a scatter plots of the this is a scatter plot where the firstly import we will need to import the where pie plot. It is a conventionally import as PLT. And now get the X and Y. Get an XY coordinates of the each sample. Now spell length is in the 0th column and of array, while petal length is in the second column. Call the PLT dot scatter function, passing the X and Y coordinates, and now specify the C labels to color by clustering label. When you are ready to show your plot, call PLT dot show. Yeah, that's it. And now we will practice this example. So I have the Irish data as I imported. This is the Irish data. So I pick my X values as X values as these four: sepal length, sepal width, petal width, and yeah, this is the target value, target Y. So when we plot this particular one by one, I will execute here. So this is the head, and these are the values and column values, and where this is the head of target and column. When we plot the x-axis as a x plot, plot underscore length, width. This is the where how the data, how the points are, data points are. This is a scatter plot showing, and I'm taking the color array. When you plot with the target original, how the directly we are not doing any prediction here. We are not using any model. As it is the data, how this data is showing in a scatter plot there. And when we predict fitting, and then after predicting, this is the prediction, the new value, where when you are using the new value, this is the new values, which is I pick it as x underscore new, and I pass the output of these three new points 1, 0, 2. This is the prediction. Once this is where we are passing the model labels. This is the colors. This is the clustering, k-means clustering. Here, I use the k-means clustering for the three as a 3 n underscore cluster is equal to 3. That's what it is. 3 colors are there, but this is the k-means model. Thank you. We will connect in another session.